Hi there. We are Merlin Neurotech, a student-run neurotechnology club that officially started up this past September. Merlin is run out of Queen's University in Kingston, Ontario, and features students from a wide range of disciplines and experience levels. Although we are new to the NeuroTechX community, we make up for our newbie status in enthusiasm. When we first started out, we were inspired by a long-form write-up by Wait But Why, which summarizes Elon Musk's Neuralink as creating a WizardHat for the brain. Taking this idea to heart, we set out to accomplish this lofty goal ourselves. Despite our initial excitement, many of us were technically inexperienced, and we had to overcome a learning curve. Our first couple of projects ideas were ambitious. After a bit of struggling, we were fortunately pointed towards Alex Barachant's awesome Python library, MuseLSL. We cut our teeth playing around with the community-developed tutorials provided in the repo and slowly gained a bit of confidence. At this point, however, we soon started to lose momentum. Although we had no shortage of BCI ideas, we had a pretty huge technical jump to make. Transitioning from using community-built demo tools to actually creating our own BCIs from scratch was daunting. After hacking apart other pre-existing BCI codes for a few weeks, we realized that we really needed a set of tools that would allow us to rapidly and flexibly stream EEG data. This led us to develop our two libraries, WizardHat and BLE2LSL. WizardHat is our primary project and is a Python-based API that allows for the online manipulation and visualization of streamed data. As our club largely operates using Muse 2016 and the WizardHat operates on the LSL protocol, we have developed a backend which allows us to stream data from the BLE over LSL. This secondary BLE2LSL library currently supports the Muse 2016. Transitioning this library to support OpenBCI, however, has already begun, and we have developed the pipelines that will theoretically accept data from any LSL-compatible device. Now, we'll walk you through the user flow of the Merlin WizardHat. An EEG headset uses Bluetooth Low Energy to transfer data to the LSL outlet stream. From there, the data is captured by the WizardHat library in a LSL inlet stream. It then flows through the data handler, a class responsible for formatting, structuring, and saving the data. This data structure can then be accessed by the other features of the WizardHat. From here, the data could be transformed into a filtered dataset, plotted with live updates, and used in machine learning pipelines for BCIs. Another significant feature of WizardHat is that data is continuously written to the disk, with a track record of all data manipulations saved to the metadata file.
Beyond the inevitable bug fixes, there are many more features that we plan to add to our project. As we mentioned before, we're currently working to get our OpenBCI device up and running with WizardHat, and we won't stop there. Supporting more devices means helping more people get started with BCIs. While the Transformer class was designed for flexible deployment by the end user, we also have plans for some more built-in functionality, including additional filters, power spectrum tools, and online artifact detection. We would also like to update our simulated streamer so that it can replay recorded files. The current version of the plotter class also needs some work. There are many other things that people may wish to visualize during development, and we'd like to make that as easy as possible. Finally, we think that the project could benefit from some step-by-step tutorials to get people used to the WizardHat workflow. As with any project, the development of WizardHat was not without its challenges. The first hurdle we had to overcome was deciding on a productive club structure. Moving forward, we plan to restructure Merlin to more closely resemble an engineering design team. Streaming and manipulating data in real time is no easy feat. Fortunately, we had some experienced object-oriented programmers to help us out, but this definitely took a lot of trial and error. Moving forward, we might still have to make some more changes to ensure maximum flexibility for everyone. It's also really difficult to predict the many ideas that people might try to implement with WizardHat. Moving forward, we'll definitely rely a lot on community feedback to help tweak the project. Finally, as we mentioned before, visualization still needs a lot of work. We decided to take a cue from Muse LSL and go with VizPy for its fast GPU processing. Unfortunately, none of us has very much experience with OpenGL, and we may ultimately have to go in a different direction for visualization to ensure maximum flexibility. Thanks for checking out WizardHat. We're really excited about the future, and hopefully we're not alone in seeing the potential for a flexible BCI development tool.